just hooked to the plastic. And the purpose of this is so that you can hear the spark when the boards go into ignition. So let's make sure the sensors are in the off position. We'll turn both testers on and we'll wait another 15 seconds. This is going to get time consuming, and if you think that's something, look at all these boards we got to go through yet. Anyway, when they go into ignition, if you were to watch this spark versus this one, I'll sense a flame. This is really snappy. This puny little thing over here might be a problem. So a test like this will say, okay, I got a nice hot spark, and you can also test whatever other features it is that you want to go through on these boards. I've connected another 230587 to the tester to illustrate what happens when you get a dead board. You turn it on. Do I have a check light? Yeah, I have a check light. In 15 seconds, I should get the valve open, sense a flame, do the whole sequence. I could sit here and tell you some jokes, and the longest joke I know will be over with before this thing goes into ignition, because it's a dead board. Okay? It's not going to ignite, it's not going to open the gas valve, it's just going to sit there. Typically dead boards, all 4 feet in the air. Turn it off, throw it away, get a new board. Here we have another 230587. You're going to see that it's a faulty board. When we turn the tester on, we're going to wait for the board to go into ignition. We have the NC check light. I'm going to point out after we test this board that you don't always get the NC check light on boards like the 230587. There's ignition, sense a flame. That's going to keep the igniter going if that circuitry is working properly. But there is no valve light, which says this board is definitely faulty. Whether it's a relay problem, an etch problem, or some other control problem, this board is not good. What I want to point out about the NC check light is that if you look at the fingers of these 230587s, they do not have the terminal identified as NC on the edge of the board. The NC is the normally closed contact on these relays, and it actuates, in water heaters and refrigerators, the indicator light on the operator panel. These relays are constructed in such a manner that there are no contacts in here for that terminal, but there is an electromechanical stop so that when it comes up to the top, in most cases you're going to see the NC check light. Doesn't have to be there. As long as it opens the valve, the board's functioning properly. Now that's the 230587. Another board you're going to run into from time to time is the old Duotherm 315526. It is an instant fire board, single try, remote sense. When I turn this board on, it'll very quickly go from NC to valve and into ignition, and I sense a flame off the remote terminal, and it will sit here and run until such time as I suppress the spark. If I had the clip lead hooked up, it'll time out in about 6 seconds and shut off. Now this particular board happens to be a good board. Here's another Duotherm 315526, and I've selected this board because it has a problem. If I turn the tester on, it goes into ignition. I'll sense the flame. But now watch what happens when I mechanically move this component. This little transistor has an intermittent solder connection which allows the board to function or not, depend upon where the pressure's at. If I tweak the board, it might run, it might stop. But in any case, it's obviously a faulty board. I used this particular board because one of the things we pointed out in our very earliest video on the company is the fact that with the 230587 board, The highest failure problem on these boards are intermittent fractured solder connections. So when you've got a board hooked to the tester and it's operational, and it's turned on and it goes into ignition, well, I'll wait for a minute until it goes into ignition. One of the things you need to do to determine whether the board is good or whether the board might be good is once it goes into ignition and opens the gas valve, we're going to sense a flame, and then we're going to take this board and very carefully, and I say very carefully because there's 150 volts DC on this capacitor. Take these four corners and flex and bend and beat and tweak the components like I did on that 315526 board. If it glitches once, you've got a bad board. If it doesn't glitch and you go into the timeout phase, you might have a good board. This early duotherm board, part number 315526, as we mentioned, was an instant fire board, single try remote sense. So far, all of the boards we've used in demonstration are remote sense. They continue to spark until you suppress the spark, which is normal in the appliance by virtue of the conductivity of the flame. This board was replaced by duotherm with the first, as far as we know, of the 3-try boards. Those boards which will try 3 times to ignite the gas before they lock out. This board, number 318816, incorporated that feature, and in addition to being a delayed 3-try board, it also incorporated what we call an enhanced cutoff feature. The minute a flame was sensed through the finger electrode, it stopped the ignition process. That's different than what we were doing with these. So when I turn this on, we'll wait. We should have a check light here. We should get the valve open. This particular board should go through 3 cycles of trying to light the gas. If you sense a flame on any one of the 3 tries, and then flame sense is lost for some reason, the board will go through another full 3 tries. Flame sense on this in the remote position stops the ignition process. Turn it on, goes back into ignition immediately. And now we're going to go through another whole 3 tries. Same thing holds true with this board. Turn it on, sense the flame, flex, bend, beat, tweak. If it passes all that, you might have a good board. Second try. In 15 seconds and 2 really quick jokes from now, we're going to have the 3rd try. At least I hope we do. And that's the 3rd try. So we will discontinue this one. The board that I have hooked to the tester at the present time is an Atwood board. They're obviously all made by Channel Products Corporation. But it has the external sense feature. The external sense feature must be connected to this little alligator clip in order to sense the flame. Now, since the external sense feature comes over here and connects into the S1 terminal, when we go to sense the flame on this, we're going to have to go to the remote position. When I turn this on, most water heater and refrigerator boards are instant fire boards. So when I turn this on, it goes 1, 2, is this one going to work? We go into ignition. You can hear this thing chirping. I sense a flame in the down position, and this will continue to ignite and keep the gas valve open. Now, in reality, if this was installed in the water heater or the furnace, this board, the conductivity through the flame would be suppressing this spark. If I disconnect this and hook it up here, go to this position, you can tell by the way it's singing, if you can hear that, that we've sensed a flame and gone through the timing cycle. This is a very similar type of a board. This one's called Gaslighter, but whether it's Gaslighter or Stoll or Atwood, they're all a product of Channel Products Corporation. Turn this one on. We have the external sense wire hooked up. Goes into ignition. Sense a flame to keep it running or suppress it, and it's going to time out because I've disconnected the flame sense. We should go back over here to the NC check. Eventually. The board that I have connected right now is a very popular Suburban board, 231741. It's a delayed 3-try board, local flame sense. Turn it on. We're going to have roughly a 15-second wait. We could let it go through all 3 tries, but when it goes into the first ignition cycle, we'll do the local flame sense. Stops the ignition process, keeps the gas valve open. And again, don't forget to flex and bend and beat and tweak to find out whether there's an obvious intermittent. It looks like the board is good. And I'll repeat myself, and I'm going to do it more than once, okay? If the tester says the board is bad, pitch it. If the tester says the board is good, you don't know when it gets hot, cold, humid, mechanically flexed, ratty voltages, is it going to work or not? I've got a couple of the newer Atwood water heater boards here where they're all potted, 2 mounting tabs. This is the earlier one, part number 93257. According to my specification sheet, that's a 1-second delay, single try, local, but with retry circuit board for water heaters. When you connect this up, you want to make sure you get these pins on the right side because they've got the connection pins in here. So you hook that up, hook the high voltage wire up, turn it on, goes into ignition, tick, 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 tick. I would have to have this connected to that if I wanted to sense the flame. Very similar board, except that this particular board is a 3-second delay and a 3-try local flame sense. Now, looky here. They've added a fuse. I guess the fuse that we've been putting on our boards for 10 years wasn't such a bad idea after all. Hook this one up, expect it to perform like it should. If you don't get anything, the first thing you want to do is check this little 2-amp fuse. Otherwise, it goes into ignition, we sense a flame. Basically, that's it. This is not the kind of board you can flex and bend and beat. Well, I guess you could a little bit, but not enough to be significant. The board I have hooked to the tester now is a Suburban 231427. This board is a single try board, it's delayed fire, and it is remote sense, senses off the fingers. So I've connected the